In this video, we'll be evaluating trig functions with the calculator and solving applications involving right triangles. To review, trig functions follow the acronym of SOHCAHTOA with right triangles, where the S represents sine, the O represents opposite, the H represents hypotenuse, C represents cosine, adjacent, hypotenuse, tangent, opposite, and adjacent. These actually create the acronym of trig ratios. So the sine of an angle equals the opposite side divided by the hypotenuse, and so on. Again, when you think about the hypotenuse, opposite, and adjacent legs, hypotenuse is always opposite of the right angle. And depending on what angle you're discussing is going to represent which side is going to be opposite and which side is going to be adjacent. So for example, in this angle, if this was the person that we were discussing, then the opposite side obviously would be over here and the adjacent would be down here. If we were discussing this angle up here, then these two would switch. This would become the opposite because it was opposite of that angle. This would become the adjacent. Hypotenuse never changes because it is always across from the right angle. Now, there are actually 6 different trig functions. We have reviewed sine, cosine, and tangent, but there is also cosecant, secant, and cotangent. Now, the very interesting thing about these is that they are opposite of one of the original trig functions. So cosecant and sine are opposite of each other. They are reciprocals of each other. If sine equals the opposite over the hypotenuse of a triangle, then cosecant actually equals the hypotenuse divided by the opposite. Cosine and secant are reciprocals of each other, and tangent and cotangent are, again, reciprocals of each other. So when we discuss 6 trig functions, we are actually talking about sine, cosine, and tangent, and then we are talking about their reciprocals. Now, we can actually evaluate the 6 trig functions of a triangle. So for example, if we are talking about this angle alpha, I can say that the sine of alpha is going to equal my opposite, which we know that this is always the hypotenuse. And because we're dealing with alpha, this becomes the adjacent because it is adjacent or next to the angle. And this becomes the opposite side. So sine of alpha is going to be the opposite divided by my hypotenuse. So the sine of alpha is 8 over 17. The cosine of alpha is going to be my adjacent over hypotenuse, which is 15 over 17. And tangent of alpha is going to be my opposite over the adjacent, which is 8 over 15 when you think about SOHCAHTOA. Opposite, hypotenuse, adjacent, hypotenuse, and opposite, adjacent. Now, because we're dealing with these 6 trig functions, we can now do the reciprocals. The cosecant of alpha is going to be the reciprocal of sine, so it will be 17 over 8. The reciprocal of cosine is secant of alpha, so it will be 17 over 15. And the cotangent of alpha will be the reciprocal of tangent, so it will be 15 over 8. So at this point, in order to be able to solve the problem, what we have here is we have an angle, but we do not have all 3 sides. We actually need to find this side in order to find all of the ratios. So what we will have to do is Pythagorean theorem. So if I say that this is x, I know that x squared plus 6 squared is going to equal 11 squared. So x squared plus 36 equals 121. So I know that x squared equals 85, I believe. Yes. Therefore, x is going to equal the square root of 85. Now that I know all 3 sides, I can now find the 6 trig ratios. So sine of this theta is going to be opposite over hypotenuse. So since we're dealing with this angle, I'm going to go ahead and write what each part is. So according to this angle, this would be my opposite side because it's opposite the right angle. This would be my hypotenuse because it's opposite of the, 6 is opposite of the angle. The hypotenuse is opposite the right angle. And then this would be my adjacent. because it is next to the angle. So sine of theta is going to be opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. Now, the reciprocal functions, cosecant will be the opposite. Secant, again, will be, not the opposite, I'm so sorry, the reciprocal. And cotangent will be the reciprocal of tangent. Now, back in Algebra 2, you learned about radicals and the fact that radicals cannot be in the denominator. So in many instances, for example, with secant and tangent, this would probably not be your final answer. They probably would have this simplified to where a square root cannot be in the denominator. Now, when you're evaluating with a calculator, the first thing you need to do is you need to check your mode, and you need to make sure that your calculator is in degree mode and not radian. So go in and make sure that degree is highlighted, because if radian is highlighted, you will get a very, very weird answer. Now, if you are trying to find a side of a triangle, and let's say you know the angle, let's say the angle is 30 degrees, and you actually want to know what is sine of 30 degrees. Therefore, you will just type that into the calculator just like it shows, sine 30, and hit enter, and you would get the number 0.5. So for example, let's attempt to solve either a side, or in a minute we will be solving an angle. So in this case, we have an angle, and according to this angle, this is our hypotenuse, and this is our adjacent side, because across the right angle is going to be the hypotenuse, and this is the side that is touching the angle, so it's adjacent. So we are using A and H. So if you think of SOHCAHTOA, the A and H is represented by cosine in this case. So therefore, the cosine of 37 degrees is going to equal the adjacent divided by the hypotenuse, x. And now we have a basic equation that we're going to solve. So to solve this, I'm going to show you the long way to solve, and then there is a little trick. So we have a variable that is in the denominator. We do not like denominator variables, so therefore I need to multiply both sides by my denominator so that I will get x out of the denominator. And now we have x times some number, so all we have to do is just divide. So we'll get 11 divided by cosine of 37. And if you put that entire thing in the calculator, you will get 13.77. And so therefore, x, the hypotenuse, represents 13.77. Now, there is a trick. Anytime you have a variable in the denominator, it actually happens that it switches places with what is on the other side. So this cosine of 37 that's on the other side will actually switch places with the x in the denominator, and the x will switch places with that, and they will be able to swap as a little trick. So let's try this one over here. So in this case, here's our angle. This is automatically our hypotenuse because it's opposite the right angle. And this again is our adjacent side because it is the side that is touching the angle. So again, we're using A and H, which happens to be cosine. So cosine of 60 degrees equals the adjacent divided by the hypotenuse, which is 11. So to solve for x, we will need to multiply both sides by 11. And we have now solved for x. And so in the calculator, all you have to do is just multiply 11 times cosine of 60. And you will get 5.5 for your side. And last, this just so happens that this is also a cosine because according to this angle, this is your hypotenuse because it's opposite the right angle. And this is your adjacent side because it is the side touching the angle. So A and H, again, represent cosine. So cosine of 47 equals the adjacent divided by the hypotenuse. To solve, we're going to multiply both sides by 3. And therefore, in the calculator, you'll multiply 3 times cosine of 47. And you will get 2.05. Now, when you are looking for an angle, so in the past we talked about like the cosine of 30 degrees was 0.5. So if we were to work backwards and we wanted to know what is the angle degree of something, let's say we had a ratio of the sine of an angle equals, like, let's say 1/3, and we wanted to know, well, what was that angle degree? This is where you will actually take the inverse of a trig function in order to actually find the angle. So anytime you're looking for an angle, you will take the inverse of what it says. So in your calculator, you will do second sine, because that will give you the inverse, of 1 divided by 3, because it is 1/3, and it is going to give you, and it would give you 19.47 degrees. Please do not forget the degree, because it's not 19.47. That is an actual degree. So make sure you do include the degrees for that. So let's attempt these, knowing how to find the angle. According to this angle, this is your hypotenuse, because it is opposite the right angle. This is your adjacent side, because it is the side touching the angle. So A and H, I'm going to rewrite SOHCAHTOA again. So A and H represents cosine. So we know cosine of our angle is going to be the adjacent divided by the hypotenuse. So this is where you would have to do the inverse of cosine, and you would get 22.6 degrees. So I'd like for you to pause the video and attempt to do these next two problems to find the angle measure. Okay, for this next angle, this is our opposite side, because it is opposite the right angle, and this is our adjacent side, because this is the side that's next to the angle. The hypotenuse is not being used here. So O and H actually represents tangent. So the tangent of theta represents the opposite side divided by my adjacent side. So since we're looking for an angle, we are going to take the inverse of 11.9 divided by, and you should get 49.95. Don't forget, it is a degree. In this last one, this is the angle, this is the opposite side, and this is the adjacent side. Again, the hypotenuse is not being used. So again, we'll be using tangent. So the tangent of our angle represents the opposite, which is 4, divided by our adjacent, which is 13. So since we're looking for the angle, we will take the inverse, and we will get 17.1 degrees.